Next on stage is Manfred. I have to tell you something about Manfred. Manfred is something very special. I mean, I use this phrase special very often, but Manfred is really very special. Caption this. There is a guy in a stadium, just where football, soccer is played, right? This stadium. You call it also stadium here? Like this, okay. And this is a conference and he's talking on a stage. This is Manfred. There are about 70,000 people are sticking to his and following every single word he's telling. And he's live coding on a stage, totally calm, and then something happened totally horrible. His laptop makes something like blows up and starts to burn. It explodes everywhere, where is fire, everywhere. All the guys behind the stage start yelling around and screaming. Manfred stays calm, says, okay, folds the laptop, put it in his backpack, wherever, put out the pen and said, okay, let's go. This is Manfred. There's no one else who I ever met who is that calm on stage. You will see it now. Welcome, Manfred.
Thank you. Hello. So I don't know at all why everyone thinks I'm that calm. So it's great to be here, and it's great that so many people want to build with me sustainable architectures. Let me start with a short question, namely, what do you think, what does it take for a good software architecture? When you think about your past, about your experience, what does it take? So if you ask me, it takes a group of diverse people where everyone can bring in their own experiences. And perhaps there's a moderator, a software architect that helps that everyone does its best to produce an architecture. Of course, this is the most vital part here. And there are some other parts you can do to improve your architecture, especially to accelerate the process of creating an architecture. For instance, you could give them some caffeine and you could feed them with pizza. I've made a lot of good experience with pizza. Personally, I prefer the pizza provinciale. You know, it's the pizza with corn and with ham on it. I have only made good experiences with it, so I can only recommend it. But if we come back to experience, people tried to find out how we can share experiences. And so people started to write down best practices. And other people did it a bit more formal. They tried to write down patterns. And then other people took some patterns, they took some best practices, they took a philosophy, and they added everything to a methodology. And such a methodology is domain-driven design. Domain-driven design shows you how you can get from A to B, how you can start with your requirements and end up with your architecture. And this is also what this talk is about. In this talk, I will show you how you can use domain-driven design for providing a sustainable architecture with Angular. When I'm saying this, two things are important for me. The first thing is it is about sustainable architectures, not a quick and dirty architecture. It is a sustainable architecture we need for long-term maintainability. Modern business applications have to be maintained for quite a long term. 20 years, perhaps 15 or 10 years is not seldom. And the other thing is, it is about ideas from DDD, from domain-driven design. For me, domain-driven design is not a religion, hence I'm just taking out the ideas that fit for me and I try to use these ideas to reach a specific goal. When we look at the contents of this talk, first of all, I will talk about strategic domain-driven design, which is one of the two main parts of DDD. It deals mostly about architecture. Then I will talk about the Angular monorepo, and then at the end I will try to bring both sides together. I will show you how you can use both the methodology on the one side and the technique on the other side. But first, let me introduce myself. I'm Manfred. I'm a trainer and consultant for Angular. I'm part of the Google Developer Expert team, and since beginning of this year, I'm part of the Angular team. I'm a trusted collaborator there. My current product is also about Angular. It's a workshop about Angular in the enterprise. It contains a lot of stuff you need to build sustainable architectures. We are doing it as an in-house workshop and also as a public workshop in some selected cities. Okay, let's get started with the first chapter. Let's get started with domain-driven design. When you look at domain-driven design, you see two main things in there. The first thing is strategic design, the other thing is tactical design. Strategic design is all about decomposing a big system into tinier parts. And this is what architecture is about, isn't it? Because we don't want to have this big system with thousands of classes, thousands of entities. Instead, we want to have several tiny pieces that are less complex and more maintainable. Tactical design, on contrary, is more about design patterns and practices. So the first is more about architecture, and the other thing is more about what we would call design nowadays. And because of this, I will focus here on strategic design. If you ask me what strategic design is doing, I would say strategic design tries to prevent this very situation here. A situation where everything is intermingled with everything else. Normally you want to avoid such a thing, because when everything is intermingled with everything else, then you cannot easily change something. When you change something here, you introduce a breaking change over there, and so this is not what you want to have. Let me give you an example. The first big system I wrote about 20 years ago was an e-procurement system. And of course, we could write an e-procurement system as a big application that can do everything, or we could, instead of this, try to implement several tiny applications, like a catalog application or like an approval application, where the manager is saying you don't get this product, or an ordering application that sends out the orders to the best vendors, or we also had a specification application where an export said, hey, you are not allowed to use a CD burner. This was the big example back then. The CD burner was not allowed for everyone. Nowadays, no one knows what a CD burner is anymore. If I ask my boy, my son, what a CD burner is, he will not know it, I guess. Well, perhaps this is also because he is only 3 years old, I don't know. Anyway, it shows how time changes. In domain-driven design, you would call these subdomains. And this is the goal of strategic design. You try to subdivide your whole application into subdomains that are more or less self-contained, that more or less don't need to know much about each other. One nice thing about subdomains is that each subdomain has its own data model. For instance, here the catalog has its own model and the approval system has its own model. And you create those models in separation. That means those models are not intermingled with each other. When you look here, we have a product on both sides. We have a product in the catalog and we have a product in the approval part. But both products are different. When it comes to the catalog, the product has a lot of properties, like the description, like different prices and perhaps discounts, like a lot of pictures and Q&A. When it comes to approval, all those data is not important. The manager who has to approve a specific order needs the price, the title, and something that's very important there, the budget. They need to assign this product to a specific budget they have or have not. So as a scene here, both times we have a product, but those are different products, and we don't even try to create one unified model, because in this case we would end up with a very intermingled situation. In domain-driven design, they are calling this a bounded context. The bounded context is the border within one model makes sense. Outside of this bounded context, the model does not make any sense, because outside of this border, the product might look somehow different. And within this bounded context, we have this general language. This general language everyone should use. That means that we technicians are also using the language of our customers, of our stakeholders. And this brings two things. The first thing is our application is a mirror of the real world. And the other thing is it is easier to communicate if we all are using the same words for the same things. One thing you also need after creating all your subdomains is a context map. The context map shows you which subdomain needs some data from other subdomains. In our case, for instance, the specification domain could need some data from the catalog domain, most likely product data, product names, prices, pictures, something like this. And the same holds true for approval and for ordering. All of them will need some data from the catalog. And of course, it is a really bad idea to grant all those domains full access to the catalog. If they have full access, we have one more time this intermingled situation, which makes it difficult to change something. So what you see here is not the best idea. A better idea can be shown on this slide. Here we have something like a shared kernel, which is a common library or a bunch of common libraries, libraries shared by all those domains. But also the shared kernel is not the last word on this, because you know, if everyone is responsible for a common library, at the end of the day, no one is responsible, and so introducing breaking changes is very likely. That means we need something better, and this could be an API. Just a small facade that is exposing specific things for other domains. Not everything, just specific building blocks, specific components, specific services. Everything that is exported here needs to be somehow backwards compatible. Everything else can be rewritten and changed all the time. And in domain-driven design, you also call this an open or a host service. I'm just going with the word API here because it is a bit shorter and the rest does not fit into this black rectangle here. When you look into domain-driven design, you will see a lot of further techniques for communication between your domains. So now, after I've shown you a bit of a methodology, let's have a look to the technique. Let's have a look to monorepos in Angular. Who is using monorepositories so far in Angular? Okay, some of you, okay, great. So a monorepo is nothing else like this. It is a big repository containing a lot of different projects belonging to your software system. That means you subdivide your big application into tiny parts, and all those tiny parts, applications or libraries, go in here. And one of the best things of this monorepo is this node modules folder. Not that it is here, but that it is here just once. That means you just have one version of Angular, one version of RxJS, one version of Bootstrap. Just imagine what would happen if you had Angular 5 here and Angular 8 there. And then you try to compile everything together. I guarantee you, all hell would break loose if you tried this. So it is somehow a good thing that we have one version policy in here. Creating a monorepository is quite easy. You need the CLI. You can new up a new project, and then within this project you can generate applications or also libraries. You can serve your applications, you can build your applications as well as your libraries. It is really as easy as that. When you go with monorepositories, you have a lot of advantages. One advantage is everyone is using the latest version of your library, because the latest version of all the libraries is part of your monorepository. When the newest version lands in the master branch, all the other sub-projects will use it, because they are located under ... library name. You don't end up with version conflicts because you have this evergreen version strategy. You have just one version of dependencies within your nodes modules folder. You don't have the burden with distributing libraries. You don't need to assign a new version number. You don't need to npm publish your package. You don't need to npm install it. You don't need to make sure that everyone is using the latest and greatest versions. Just create a new folder, check it into source control, and you are happy. And saying this, there is a lot of good experience with this out there. For instance, at Google and Facebook, people have used this quite heavily, but also in some other areas of software development. For instance, if you're doing .NET development, you're doing this for 20 years without even thinking about it. Because in .NET, in Visual Studio, what you get by default is just a monorepository. They call it a solution. And perhaps you have used Eclipse so far. Who has used Eclipse? Some of you, yeah, there is this notation of a workspace which can be used the same way. One of the good things of the monorepository is it is not a one-way street. Just imagine you have this monorepository with all those libraries, and as you are developing on them, they are quite major. And now you want to share your validation library. And so you can just export it to an npm registry, which means you get the best of both worlds. You have it within your own monorepository, you have not a burden with distributing everything, and your colleagues and the other projects can just grab it via npm, the best of both worlds. If you say, yes, this is a very good idea, monorepositories, I like this idea, I need this, in this case, I want to encourage you to have a look into NX. NX is what I'm calling the sugar dip on top of the Angular CLI. With NX, you get a traditional CLI project, but it is somehow enhanced. They are using some extension points for providing new features. Most of them deal with mono repositories. One of those features is you can easily visualize your project structure, all your libraries, and which library is depending on which other library. And one more time, you need this because you want to prevent this intermingled situation. Okay, so far we have seen two parts of the same coin. We have seen the methodological side of the coin, which was about domain-driven design. We've seen the technical part of the coin, which was about NX and mono repositories. And now let's try to bring both together. If we want to bring both together, we would start with our domains, the domains we have identified. And then we would add an artificial domain, which is just a shared area. You could call it the shared kernel with terms of domain-driven design. After this, you begin to fill your domains with libraries. For instance, you could fill them with feature libraries. A feature library is a library that contains smart components, components that know about the use case. Another kind of library are UI libraries. A UI library contains dump components. A dump component is a component not aware of a specific use case, and because it is not aware of a use case, it can be reused quite easily. Think about a date-time picker. A date-time picker knows nothing about your use case. And because it knows nothing, it can be used together with all the use cases out there, dealing somehow with this or that date. The next layer is what I'm calling the domain layer. It contains your domain logic, validation logics, and also your data models. And then you have a utility layer, which contains technical utility stuff, like authentication stuff or logging and so on and so forth. After you've done this, you can easily introduce access restrictions. And one access restriction here could be that only one layer is allowed to use layer below it. So in this very case, the feature layer is allowed to use everything else, but the domain layer is only allowed to use the utility layer. One layer is only allowed to use other layers below it. And this one more time prevents that everything is intermingled with everything else. It also prevents cycles, by the way. Another access restriction would be that each domain is only allowed to talk with itself and with the shared part. In our case, catalog is only allowed to talk with other catalog libraries and with shared libraries, and the same holds true here for ordering. The ordering domain is only allowed to talk with other libraries of the ordering domain and with libraries of the shared domain. Sometimes you need to access another domain. For instance, it could be the case that the ordering domain needs specific components or services from the catalog domain, because this is where the products are located. And for those cases, you could introduce an API. An API is just a tiny library exposing specific things to other domains. Not everything, because we don't want to have everything intermingled, just specific things. And so the ordering domain can use those exported things, which need to be more or less backwards compatible. One more time, everything else can be changed, but this API and everything exposed by it needs to be backwards compatible. If you're saying, yes, that looks nice, it looks tidy, it looks cleaned up, but somehow it's overwhelming, I'm telling you, no, it's not that overwhelming. It's not that overwhelming because, first of all, you don't have a full rectangle like here. Most of the times, you just have feature libraries, domain libraries, and APIs within real domains, and the reusable UI libraries with your design system, for instance, the reusable utility libraries are located in the shared part. Most of the times, of course, sometimes there will be an exception. And the other thing is, creating a library is not difficult at all. Creating a library is only as difficult as creating Angular modules. Both is a matter of just one command line command, so you could really introduce all those libraries without much effort. When we talk about the domain itself, it is a good practice to isolate the domain. And that means that the domain gets something in front of it and something below it. In front of it, we have something that's called the application layer. The application layer contains use case specific facades. A facade is just a service that provides everything you need for one use case. That means if you have 5 use cases within your application, you have 5 facades. And this facade can only do state management. Also do state management. It can hide a state management library like Redux, NGRX, Akita or something like this. It can even use just behavior subjects. The good thing is the rest of the application does not know how state management is performed in here because the facade is shielding it away. As you've seen here, the domain layer contains entities and the business logic, and the infrastructure layer contains your data access logic. It communicates with the backend. Of course, you can put everything into separate libraries, but normally I'm not doing this because it has to stop somewhere. And with this approach, I just would end up with far too much libraries. Instead, I'm putting those 3 things into one library, but I try to separate those 3 aspects with 3 separate folders. Talking about layer, you don't have to use layers. Meanwhile, there are some alternatives to layers. You can use hexagonal architectures or clean architectures or something else. It does not really matter. But what matters here for me is it is vital to subdivide your application into specific parts. In my case, those parts are slices, vertical slices and horizontal layers. And then you need some kind of access restrictions so that not everything is intermingled with everything else. And for this, I want to show you a short demonstration. So, what I've prepared here is a simple application that contains the domains we've discussed before, and this application has been written with NX. That means it is a traditional CLI application enhanced by using some extension points. And one of those extension points is not only creating a project folder, instead it's creating an apps and an libs folder. I think you all can assume what's in there. When we look into libs, we have 3 subfolders, 1 subfolder per domain. There is 1 subfolder for the catalog, 1 subfolder for the ordering domain, and 1 subfolder for the shared kernel. When we look into ordering, let's look into catalog, we see a domain library that contains all the domain stuff, models, facades, and so on and so forth. So perhaps we should look in there. Let's have a look here to a facade. Product service, yeah, this is my facade. And as you see here, the facade is just providing everything we need for a specific use case. Here it is the use case for searching products. It just provides the state for this use case, which is here just a behavior subject, and it provides methods to deal with this state. And because of this, we can easily exchange this point here, this state. We could move it into a state management library, into an ngrx store or something like this. One nice thing about all those libraries is this index.ds here. I'm always saying this index.ds is reason enough to subdivide an application into libraries, because this here is another facade, a facade that controls what goes out. The consumer of the library only sees what's exported here. If you aren't exporting here a specific class, the consumer cannot see it. That means you can have secrets, and having secrets is a good thing. It is a good thing for a robust application, because everything you keep a secret can be changed afterwards. Everything you are exporting here needs to be, backwards compatible. Okay, here I am exporting some entities and some services and of course a domain module. So let's have a look into another library. Let's have a look into a feature library, feature browse products. And here of course the catalog domain module is imported. It is imported from this logical name here. This logical name is trinary. It contains the name of the project, the name of the domain, and the name of the library itself. So this also makes sure that you have a clean code, that you don't end up with, dot dot slash dot dot slash dot dot slash dot dot, and so on and so forth. And it's nice because your source code does not assume where this library is located on your hard disk. So you can move your library around. You can even exchange the library by another one. Of course, at the end of the day, the compiler needs to know where those libraries are located, and this is defined currently within dsconfig.json. Here we have path mappings that tell the compiler where a specific library is found on the hard disk. And now you can do funny things. For instance, you could say, hey, I have this special customer, and the special customer pays me a lot of money to implement this feature in a very specific way for them. And that's why when compiling, I'm pointing to their implementation and not to the default implementation. That means you can easily exchange your libraries. Perhaps you've seen it, I'm using comments in here, and comments are not allowed within JSON files, but do you know what? Sometimes you have to risk something. This really makes me feel alive. It really makes me feel like a runabout. No, just kidding. In real life, I would not use comments at all. In real life, I would use several dsconfig files, and I would point to this or to that dsconfig file when compiling the application for this or for that customer. Okay, a lot of flexibility. But let me also show you another thing that's quite nice when it comes to NX. NX installs an npm script that's called depgraph. dep-graph. And it shows you the structure of your libraries. And now, as in every romantic movie, I'm saying, let's do something crazy. Let's start Edge. And within Edge, I'm using a cool feature. I can paint here. Look at this, my favorite feature. When we look at all these bubbles, we see some bubbles are about the catalog domain. For instance, here we have a feature from the catalog domain. Yeah, this color can be seen. This is a good projector. Here we have another feature from the catalog domain. And here we have the domain logic for catalog. Catalog also comes with an API. On the other side, we have something from the ordering domain. It's also a feature. And we have the domain logic for ordering domain. And then we have some shared stuff in here, like a shared UI library with address components and a shared utility library with authentication stuff. So by looking at those colors, you clearly see that it is not allowed that you just grab into another domain. If you need something from another domain, you have either to use the shared part of the application, or you have to use an exposed API. But you are not allowed to directly grab over and use something there, which is kind of nice if you ask me. But now let's do something bad. According to my layering rules, accessing an UI library from an utility library, is not allowed. That means doing something like this breaks my architecture, because the utility library is on the bottom and the UI library is more on the top, and it is also only allowed to access things from top down, not from bottom up. So let's try out what happens when we do this. For this, I'm switching over to my shared util auth module. And here I have already prepared the bad line of code that is importing a module we are not allowed to use. And as you see here, we are getting some errors. We are getting a linting error. The linter tells me, hey, a utility library is only allowed to access other utility libraries. This makes sure that my architecture does not break. Of course, we can do the same on the command line. tslint, nglint, and I'm pointing to the project shared util auth. And then we get the same error. And I really like this. Why do I like the console? Well, it's not because I'm old, but because when it appears on the console, I can script it. That means I can integrate it into my CI process, and I can integrate it into my check-in rules. I could use something like Husky to prevent that code that breaks my architecture is checked in into source control. And this is normally what we want to have. We don't want to have broken code or bad code within our Git repository. Kind of nice. Perhaps you are wondering how we can configure these access restrictions. And the answer is, when we are going with anx, there is a file maintained for us called anx.json. And this anx.json file contains an entry for each and every library. For instance, an entry for my catalog feature requests product library. And here you can assign tags. A tag is just a string. It could be everything. For instance, if you want to look cool, a base64 encoded string, so that everyone thinks, hey, this guy, this girl is capable of calculating base64 in their head. No, please don't do it. It's not a good idea. What I'm doing here is something that aligns with best practices written down by the guys and, in general, people at Normal. They said, please tell the tooling here in which column and in which layer your library is located. So think about my architecture matrix. It had some columns, domains. It has some layers with libraries. And this is what is reflected here by those tags. For instance, here I'm telling anx, hey, this library is part of the catalog domain. I think it was the first column, wasn't it? And I'm telling it, hey, it is part of the feature layer, which was also the first layer, if I remember right. I would do this for each and every library, and after I've done this, I can easily introduce linting rules within my TS-lint JSON. For instance, here I could say, hey, the catalog domain is only allowed to access other things within catalog and to access things within shared. And ordering is only allowed to access things within ordering. It is allowed to use the API of the catalog, and it is allowed to use the shared domain. And to be complete, shared is only allowed to use stuff within shared. Those are the horizontal restrictions, the restrictions from left to right. I have also some vertical restrictions. For instance, here I've told the system a feature library is allowed to access nearly everything, but a UI library is only allowed to access util, and so on and so forth. So as you see here, it is quite easy to introduce access rules which make sure that your system is loosely coupled and so more easy to be changed and to be maintained. Saying this, this rule set is quite clever because this rule set does not need to get extended. It only needs to get extended when you have a new domain. This is the only case when you need a new line. But for all the other cases, it stays at ease. That means you don't need to maintain it all the time. Okay, perhaps I should show you how to generate a library. It is like ng generate module, but instead of module, you are using library. And then you are defining the name of your library. For instance, it could be a feature library for check-in luggage. And it could be placed into the directory luggage, which would be the domain here. With respect to the current version of NX you are using, you are getting more or less questions. The newer versions are asking less questions. And after answering those questions, a new library is generated. So as you see here, generating a library is just as easy as generating modules. And it has a lot of advantages, as you will see on the next slide. So if you look here, you see that using fine-grained libraries instead of fine-grained modules has one big advantage. The library can become the unit of recompilation. That means NX is not recompiling everything all the time. NX tries to find out what changed, and then NX is only recompiling the changed applications. If you have 20 applications in your monorepo and just one changed of them, then just this one is recompiled. The same holds true for testing. It can be the unit of retesting. When you just change one library, then only this library and all the other libraries depending on it needs to be retested. You can introduce access restrictions between those libraries. This prevents cycles, and it also prevents that you have this intermingled situation where everything depends on everything else. You have information hiding. We've discussed this before. Each and every library can have its own secrets, and secrets can be changed quite easily afterwards. And now you need to be strong. ng modules will hopefully be optional in the future. The Angular team did not want to introduce ng modules back then, but for technical reasons they needed it. And since then they are seeking ways to not get rid of them, but to make them optional. And in the world after Ivy, this will hopefully be the case. Ivy itself does not need ng modules at all. The compiler is just recompiling everything for Ivy so that Ivy gets the information from the modules. But at the end of the day, Ivy would work perfectly without modules. And so we need a replacement for ng modules. And what could be a better replacement for a module as a library? because a library has all those advantages, and the library is a pure ECMAScript feature. It does not have to do anything with Angular, and I think in general that's a good idea. Whenever you can exchange a framework feature by an official browser standard, go for it. So if you like this talk, if you say, wow, this was a nice talk, then I have some nice thing for you. I have a present for you. I did not tell anyone so far, but I have announced or published a new book about this topic, and it's currently free. It's an ebook. You can download it here. It contains all the stuff I've showed you before, and also, of course, a bit more. So if you like this talk, perhaps you will also like this ebook. And if you did not like this talk, please check out the ebook anyway. Perhaps I'm writing better than I'm speaking. Who knows? So let me sum up. We have seen it is a good idea to slice a big application into little tiny parts. And it's also a good idea to organize those parts. You can use layers, for instance, but also other techniques like hexagonal architectures or clean architectures. Creating a library is as difficult as creating a module. It is just a matter of one command line command. So go for it. You have a lot of advantages. You can introduce relaxed layering, which means that one layer is only allowed to use layers below. You can use fine-grained libraries for things like access restrictions, for retesting and recompilation. And yeah, access restrictions help you to prevent this intermingled situation. So I say thanks for coming. One last thing. Remember, you need pizza and some caffeine to keep your architects awake. It is a good thing for a valid architecture. And here you have my contact data. If you need anything, reach out to me. Here you have also all the infos about my workshops. And if you want, follow me on Twitter so that we can keep in contact a bit. Thanks for coming. Have a nice day.